Hi, it's MP the tutor here, and today we're going to look at modeling quadratics, which really is just using the stuff we've learned in the other chapters to do with quadratics, but then putting a little story towards it. So here we have an example. Fred throws a rock off the edge of a cliff into the sea. The height h meters of the rock above the water at time t seconds is modeled as h equals 18 plus 8t minus 4.9t squared. Part A is what does the 18 represent? Part B, how long does it take to hit the water? And part C, what's the maximum height of the rock? So let's have a little look at these sort of questions. So part A is what the 18 represent, and that's worth 1 mark. So really, it's talking about, well, what does 18 represent? Well, if you look at it, that's what's normally called the y-intercept. But also, it's part A, it's what h equals when t equals 0. So when t equals 0, our h equals 18. Now, I would possibly also write then that 18 is the initial height. Part B. So that was only worth 1 mark. Part B is probably worth 2 or 3. How long does it take to hit the water? Well, let's have a little look at this. Well, what does that mean? Well, the rock hits the water when our h equals 0. So all we do is 0 equals 18 plus 8t minus 4.9t squared. What we then need to do is use what's called the quadratic formula. So I would use quadratic formula, doesn't really factorize, often these don't. So we have minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is the number of x squared, which is minus 4.9, or t squareds. B is the number of t's, which is 8, and c is the number of units, which is 18. So we have minus b, so minus 8, plus or minus the square root of 8 squared minus 4 times minus 4.9 times 18 all over 2 times minus 4.9. So we take that in a calculator and we get t equals minus 1.267, or we get t equals 2.900. So one of those answers isn't correct, and that's obviously the negative value for time. What this really is kind of working out is assuming that the rock goes backwards through time, back through the cliff before it's been thrown, but the calculator doesn't actually know that. So that is part B, done, where our time is 2.900 seconds. Now part C, what is the maximum height of the rock? So what we have is our h equals 18 plus 8t minus 4.9t squared. Now we could do various different things, but I'm going to go and find the midpoint of when it equals 0, because I've actually got two values here. So we could have used complete in the square, but because it's 4.9t squared, it's pretty horrible with complete in the square. So the maximum point is the midpoint of when a quadratic would be at the same height. E.g., when a quadratic equals 0. So we could have it is the max height is the midpoint of when t equals 2.900 and minus 1.267. So in this case, you go t equals, well, the middle is that 2.900 minus that 1.267 over 2. So now we work that out, that t equals 0.8165. We then plug that back into our h value. So our h is 18 plus 8 lots of 0.8165 minus 4.9 lots of 0.8165 squared, which equals 21.27 meters. Now, that is certainly one way to go about it. There is a complete in the square method, but also there is something called differentiation, which I would normally use differentiation to work out the height of these things. It is much easier, and that's chapter 12 of the first year book in Pure. And that is a much easier method once you've understood it and can then model other things to do with the height and the rate of change of height. So differentiation basically works out the gradient. So let's look at this next one. So in my car's fuel economy E in miles per gallon at velocity V, miles per hour, it's modelled as E equals 20 plus 1.2 V minus 0.01 V squared, where V is greater than 0. And part A is at what velocity does the fuel economy reach 30 miles per gallon? So this part A is find V when E equals 30. So all we do really is just plug in 30 is 20 plus 1.2 V minus 0.01 V squared. And we just rearrange and use the quadratic formula. So I'm going to take away 30 from both sides. So you get 0 equals minus 10 plus 1.2 V minus 0.01 V squared, where the quadratic formula is minus B plus or minus the square root of B squared minus 4AC all over 2A. A in this case is minus 0.01 because that's our number of V squareds. B is our number of V's, which is 1.2, and C is minus 10. We're going to plug in our values. So our V is minus 1.2 plus and minus the square root of 1.2 squared minus 4 times 0 minus 0.01 times minus 10. And that's all over 2 times minus 0.01. So we type that in a calculator and we get V equals 9.01, or we get 110.99. So that's part A then. Nice and easy. So let's look at part B. So here we have 20, it's 1.2v minus 0.01v squared equals A minus B in brackets v minus c squared. Now this is completing the square, and it would be worthwhile going back to completing the square video, which I'll put a link in the description. So what we're going to look at first is this bit here. I'm not going to too much worry about the 20. We'll deal with that at the end. So what I'm going to do is I'm going to divide everything by 0.01, so, or minus 0.01. So we have minus 0.01, and then in brackets, that makes you just get v squared. And if you divide 1.2 by minus 0.01, you get minus 120v. You still kind of have that plus 20. So I'll just put the end to that plus 20. Then we need to do that completing the square bit, which have minus 0.01 brackets v minus 60 in brackets squared. So let's do a little grid to help. We have v and v, so that gets you v squared. We then need minus 60 and another minus 60, because then that's minus 120x, so minus 60x, minus 60x, and then minus 60 times minus 60 is 3,600. So then that's then minus 3,600 plus 20. So that bit in red is the same bit I've underlined at the beginning. So that 1.2v minus 0.01v squared is that bit in the bracket. So what we need to do is take the 3,600 out of the bracket. So we have minus 0.01 times by minus 3,600. What does that equal? Well, that equals positive 36. So what we then have is our minus 0.01 lots of v minus 60 squared plus 36 plus 20. So we're pretty much almost there. So then you have minus 0.01 lots of v minus 60 squared plus 56. And that equals our 20 plus 1.2v minus 0.01 v squared. So that's pretty much the formula we want it in, although they will kind of want a at the beginning. So we end up with 56 minus 0.01 lots of v minus 60 squared. So what we're going to do now is look at part C. So part C is what's the velocity at the maximum fuel economy. Our E for the economy now is in the form of 56 minus 0.01 lots of v minus 60 squared. Now the advantage of turning this into completing the square is we go, well, the maximum is when v minus 60 equals 0, or v equals 60 miles per hour. Okay, that's nice and simple. That was part C done. Now in theory, your economy equals 56 miles per gallon. Okay, and that's part C. So, part D. Comment on this model for very high velocities, for example, at 150 miles per hour. Well, let's just plug in the value E equals 56 minus 0.01 lots of, let's do 150 minus 60 squared. Well, E equals 56 minus 0.01 lots of 90 squared. E equals 56 minus 0.01 times, well, 9 times 9 is 81 with 2 zeros, and 0.01 times 100 is 81. So our E is 56 minus 81, which makes it a really wonderful minus 25. So at 150 miles per hour, fuel economy equals minus 25 miles per gallon. Well, that doesn't make sense. So what that means is you've got a negative fuel economy. So if that was real, as you're driving down the road, the tank of fuel refills itself. That clearly doesn't make any sense. You can't get a negative fuel economy, and at a certain point you'd actually get 0 miles to the gallon. So that means you basically use infinite fuel as you're driving down the road. So over too high of a speed, the model doesn't work. As you cannot get a negative fuel economy. Zoom out a little bit so you can see it all. So that would be a typical question with regards to these models. Have a go at the questions. Now, there are only really five questions to really have a go at. And then it might be worth getting the textbook out and having a go at the mixed exercise as well, just to kind of get a feel of these models. If they're going to have just a quadratic come out, it tends to be as a model rather than just getting you to quadratic formula, because you'll do that in other questions. So pause the video, have a go at the questions, then the answers will come up on the screen now. So hopefully you managed to have a go at these questions, and I'll hopefully see you in the next video where we'll be looking at simultaneous equations.